Hello everybody. For our topic in the Chemistry in Industry project, we have chosen baking. I am Mayumi and here are my group members and their roles in making this video. So for the first part of the video, Audrey and I are going to show you how to make madeleines. Madeleines are delicate little butter cakes that are also referred to as cookies, especially known for their beautiful and distinct scallop shell shape. To prepare madeleines, we need unsalted butter, flour, eggs, granulated sugar, clarified butter, and an eighth teaspoon of salt. So for the first step, we'll mix egg and sugar. Then we will whisk it until it forms a semi-fluffy texture. This step takes quite a while, so you have to be patient. After a while, your mixture should look like this. Start adding flour bit by bit and whisk it in intervals. This will result in a smoother and runny texture of the batter. Don't forget to get the flour off the edge of the container. You can use a spatula for this. When your batter looks like this, you can start adding in the clarified butter bit by bit and stir gently as you add. Stir until the butter is evenly distributed in the mixture. Next, prepare the cold tray of the madeleine mold and start to pour in your mixture into each of the molds. To make this easier, you can use an ice cream scoop. The trays are then placed into a convection oven and are baked for 8 to 10 minutes in 177 degrees Celsius. You can slowly see the hump starting to form. All you have to do now is take your finished madeleines out of the tray and leave them to cool. And this is how madeleines are made. For the next recipe, Jessica will show you how to make cheese sago cookies. Cheese sago cookies, or sagu keju, are traditional Indonesian cookies. The combination of sago flour and coconut milk gives it a unique taste. It is crunchy and melts in the mouth. For this, you will need 400 grams of sago flour, 100 grams of powdered sugar, 65 grams of instant coconut milk, 150 grams of grated cheddar cheese, 200 grams of butter, 2 egg yolks, and 2 pandan leaves. First, roast the sago flour with pandan leaves until it feels light when stirred. Set aside in a container when finished. Next, beat the powdered sugar with butter until smooth. You need to break the butter down first so that it'll be easier for you to stir it. Towards the end, you can also increase the power of the mixer. Next, add egg yolks and coconut milk. Mix thoroughly. Then add sago flour and grated cheese. Stir until evenly distributed with a spatula. Next, you can use a piping bag and piping tip to put your sago cookies on the tray. Bake it in the oven for 35 minutes or until it's cooked at 170 degrees Celsius. Here's what the finished sago cakes look like. You can serve them with tea, or you can eat them as they are. Now, before I end the video, I want to answer some of the questions I think you might have about this video. 1. What is clarified butter and why do we have to use it? 2. What happens if we over or under stir? 3. The Maillard reaction. 4. Why use a convection oven for madeleines? So first, clarified butter. Clarified butter is butter that has been heated to separate the milk solids and water from the pure butter fat, leaving behind a clear golden liquid. This process removes impurities and raises the smoke point of butter, making it more suitable for cooking at higher temperatures. In the context of making madeleines, clarified butter is often used instead of normal butter for a few reasons. 1. Flavor and aroma. Clarified butter has a rich and nutty flavor, which can enhance the taste of the madeleines without overpowering the delicate flavors of the other ingredients. 2. Texture and structure. The removal of milk solids in clarified butter results in a higher percentage of pure fat. This can contribute to a lighter and airier texture in the madeleines, helping them to achieve the characteristic soft and spongy crumb. 3. Browning. Clarified butter has a higher smoke point than normal butter, allowing the madeleines to brown more evenly and develop a desirable golden color during baking. 4. Shelf stability. Clarified butter has a longer shelf life compared to normal butter due to the removal of water and milk solids, which are prone to spoilage. This can be beneficial for storing and enjoying madeleines over an extended period of time. Next, we have the effects of overmixing, undermixing, and proper mixing. For overmixing, excessive mixing leads to excessive gluten development due to protein denaturation and gluten formation. Gluten strands become too long and interconnected, resulting in a tougher, denser texture. It can make baked goods chewy or rubbery instead of light and fluffy. It may disrupt the activation of leavening ingredients and the even distribution of fats and other ingredients, affecting the overall structure and rise. Undermixing. Inadequate mixing can result in incomplete protein denaturation and gluten formation. Lumps may form and ingredients may be unevenly distributed, affecting the final texture and structure. Incomplete incorporation of fats and uneven activation of leavening ingredients can lead to inconsistent rising and texture in the baked goods. Insufficient mixing can also affect the even distribution of sugars and proteins, impacting the Maillard reaction and flavor development. Lastly, proper mixing ensures even dispersion of ingredients for a homogeneous distribution of moisture, leavening agents, fats, sugars, and proteins. It facilitates necessary chemical reactions such as protein denaturation, gluten formation, leavening agent activation, and the Maillard reaction. It prevents excessive gluten formation while achieving the desired texture, tenderness, and structure in baked goods. It helps produce consistent rise, even texture, browning, and flavor development in the final product. Next is the Maillard reaction. The Maillard reaction occurs during cooking and is responsible for the non-enzymatic browning of foods when cooked. It actually consists of a number of reactions and can occur at room temperature, but is optimal between 140 to 165 degrees Celsius. Here's an infographic I found about the Malliard reaction. You can pause if you want to read more about it. Last but not least, convection ovens. Convection ovens are often preferred for baking madeleines due to their ability to provide more even heat distribution and consistent airflow throughout the oven cavity. Here's why convection ovens are used. 1. Even heat distribution. Convection ovens use a fan to circulate hot air, resulting in more uniform heat distribution. This helps ensure that the madeleines bake evenly with consistent browning and texture across the entire batch. 2. Faster and more efficient baking. The circulating hot air in convection ovens accelerates the cooking process. Madeleines can bake more quickly in a convection oven compared to a regular oven, saving time while maintaining optimal texture and moisture. 3. Improved rise and texture. The consistent airflow in convection ovens helps create a drier baking environment. This allows the madeleines to rise and set faster, resulting in a lighter and more tender crumb. 4. Reduced risk of soggy bottoms. The airflow in convection ovens helps to minimize the accumulation of moisture on the bottom of the baking pan. This reduces the risk of a soggy or undercooked bottom, resulting in evenly baked madeleines with a desirable texture throughout. 5. Enhanced heat transfer. Convection ovens facilitate enhanced heat transfer through the process of convection, which involves the movement of hot air. This convective heat transfer can accelerate the Maillard reaction. That's it for our video. Thanks for watching.